Now let's take a look at some examples to really learn how to conduct this technique. So example 1, find V naught by using superposition. So clearly it requires using superposition. So we can't use nodal and mesh, even though they are absolutely sufficient to solve this circuit. Okay? So let's see what is the procedure here. So we are seeing two independent sources in the circuit, one 6 volts voltage source, another is 2 milliampere current source. So according to the concept of superposition, we are going to split this circuit into two circuits. One circuit contains only 6 volts voltage source, another is only containing 2 milliampere current source. So in the 6 volts voltage source down here, we need to make the current source 0. So how to make it 0? According to previous slide, we know we need to open this current source. That's why this portion of the circuit is gone. Similarly, on the other hand, in the second circuit, we keep the 2 milliampere current source only and make the voltage source 6 volts 0. So how to make that happen? Short it. That's why this portion looks like this. Okay, this is the first step. You need to split the original circuit into multiple easier circuits with only one independent source. The next idea is, since we are looking for the V naught, so in the first circuit, we are looking for the contribution of the V naught out of this 6 volts voltage source individually. And in the second circuit, we are looking for the contribution of V naught out of this individual current source. And then we find two V naught to differentiate with the total V naught we're really looking for. I'm using single quotation and double quotation. And the total V naught we're really looking for is equals to the sum of these two. Okay, so example 1 is pretty much providing the detailed procedure for you to understand how to go through this workflow. And then let's see the solution under the .cam. So with understanding this procedure, let's look for V naught prime and V naught double prime from these two circuits respectively. First, the first circuit with 6 volts voltage source only, I redraw it to like this. Yeah, hopefully you can see it is equivalent. To solve the V naught prime, which is here, we could apply nodal or mesh or voltage divider, since we only have one single independent source without any dependent sources. So I'm applying the voltage divider here, okay, as kind of a review. Okay. To conduct voltage divider, first of all, you need to be very clear about the connections among these resistors. You can pause the video to try to figure out what is connections among them, and then come back to listen my solution. But here, first the 6 kilo ohm here is series with 2 kilo ohm down here, and then the total is parallel with this 4 kilo ohm. And then this entire parallel is series with this 2 kilo ohm. In other words, this total parallel here is sharing the 6 volts total voltage with this 2 kilo ohm series connected with it. So with understanding this, the first voltage divider we are applying is like this. The parallel voltage, I call it Vx, is equals to total 6 volts times the ratio. In the numerator is this parallel total. 4 parallel is 2k plus 6k. Denominator is the summation of this total parallel and these 2k series connected with it. So it turned out that the Vx at this node, or say the total parallel voltage, is 3.43 volts. And if you look carefully, the Vx as total is shared between 6 kilo and 2 kilo ohm in series. That's give us the second voltage divider like this. So the voltage across the 6 kilo ohm is nothing but our V0 prime. So it is equals to the total Vx times the ratio. In numerator is 6 kilo ohm, denominator is 6 kilo ohm plus the series connected the other 2 kilo ohm. So this V0 prime is equals to 2.57 volt. Now let's see the second circuit. We are trying to find the V0 double prime here. And I redraw the second circuit here to be this way, and hopefully you can see the equivalence between them. And of course, redrawing the circuit is not something necessary. Okay, feel free to keep the original circuit and then conduct circuit analysis, no problem. And in this circuit, feel free to apply nodal or mesh. However, I'm applying current divider as a review. So obviously we are looking for the current going through 6 kilo ohm here, since it can later give us the V0 double prime. So how to find the current going through 6 kilo ohm? By applying current divider, you need to understand you need to have only 2 elements in the circuit to share the total 2 milliampere. So what you need to do is combining this 4, 2, and these 2 resistances together, right? So these 3 are parallel and then series connected, like this, right? So 2K plus 2K parallel with 4K. 6K with this total, which is equal to 10/3 kilo, is parallel, sharing the total 2 milliampere. So to find 6 kilo ohm resistance current here, we can apply this current divider. Total current times the ratio. The numerator is the other, which is the 10/3 kilo ohm. Denominator is sum of 6K and this 10/3 kilo ohm. So it turned out that the current through 6 kilo ohm resistor is equal to 0.71 milliampere. And then obviously by Ohm's law, we can find V0 double prime equals to the resistance 6 kilo times this current. It turned out to be 4.29 volts. The last but not least, the voltage we're really looking for from the original circuit is the V0. It is equals to the sum of V0 prime and V0 double prime, 6.86 volt. So feel free to try this over to justify your understanding. Alright, now let's take a look at example 2. Find V0 by using superposition in circuits A and B. So first take a look at the circuit A. We are seeing again one voltage source and one independent current source. So here's a solution. We split the circuit into 2 circuits. One is keeping the voltage source and make the current source here 0. Since it is a current source, so we open it. Another circuit is we keep the current source and short the voltage source. That's why it looks like this here. Okay. So respectively, we can apply the voltage divider and the current divider to find V0 prime and V0 double prime, and then sum them up, right? So here are the solutions for the voltage divider and the current divider, respectively. So in the first circuit, the V0 prime is the voltage across the 2K resistance. So we're looking for the voltage here in this voltage divider. Total 12 volts times the ratio. Denominator is sum of 2K and the so-called the other. The other is combining 3K and 4K by series. So once again, when you apply the voltage or current dividers, you need to be very clear that the total voltage or current is shared by 2 things and only 2 things. If more than 2 in the circuit, you need to keep one you're looking for and combining the rest. Same thing here. So basically, you're looking for the branch current here. going through the 2 kilo ohm here, which gonna give you the V naught double prime by Ohm's law. And you're seeing 2 kilo ohm here and 4 kilo ohm here. These two are series connected. So this is one branch which is parallel with 3 kilo ohm here as the second branch. So these two are sharing the total 2 milliampere current. So obviously we are looking for this branch current by current divider. And be careful, due to the current direction of the source here downwards, the current through 2 kilo ohm is upward. Okay, this is a very, very important thing. And this current is just equals to this equation. Total 2 milli times the ratio. Numerator is 3K, the other branch. Denominator is sum of 3K and this branch, 4 plus 2K. So the current through 2 kilo ohm is 2/3 milliampere. And to find the V naught double prime, we apply Ohm's law. Like I said here, be very careful the current direction. We know the current through 2K is upward, so introducing a voltage with this polarity, which is exactly opposite to the V naught double prime. So we give a negative sign in front. So negative 4/3 volt as V naught double prime. Total V naught is equal to the sum of them two. So 1/3 volt is the contribution out of this 12 volts independent source, and the negative 4/3 volt is in contribution out of this 2 milliampere independent source. A total of them is equal to total V naught induced by both. So let's see the solution for circuit B here. Okay. We are seeing 3 independent sources in the circuits. That's why we are splitting the circuit into 3 easier circuits. Here, here, and here. For example, the first one, obviously, we are keeping 12 volts voltage source and get rid of the 2 current source by opening all of them. That's why this is the resulted circuit. The second one, we are keeping the 8 milliampere current source and short the voltage source and open the other 2 milliampere current source. This is the resulted circuit. A third one, we keeping 2 milliampere current source and short 12 volts and open the 8 milliampere. This is a resulted circuit. Okay. First, you need to be very clear how and why we are ending up with these 3 circuits. And then respectively looking for the V naught prime, double prime, and the triple prime. Obviously, we have 3 results this time. In the first circuit, I end up with these 2 mesh equations. This time I decide to review mesh. The reason I'm choosing mesh rather than nodal is I'm seeing a voltage source here. Voltage source is the easiest thing in mesh equation. And obviously, to find V naught prime, we need the current going through 1 kilo ohm here, since the V naught prime is the voltage across 1 kilo ohm. And the current goes through 1 kilo ohm is nothing but this mesh 2 current. Okay. Same direction as well, very important. So I just calculate I2 and then use I2 to calculate the V naught prime. 8/5 volt is the contribution out of this 12 volts individually. So second circuit here. To find out the V naught double prime, a similar idea. I just need to find the current going through 1 kilo ohm here. Now this time I'm combining 3K and 6K as parallel to share the total current 8 milli with this 1K and 2K, because 1K and 2K are series connected. So these 2 third co basically share the total 8 milliampere. So the current flow through 1 kilo ohm is downwards, and then follow this current divider. And then V naught double prime, again, based on the Ohm's law, equals to 3.2 volt. The contribution out of this 8 milliampere independent current source individually. So the third last circuit here, again, we are looking for the voltage cross 1 kilo ohm. Therefore, we just need a current flow through 1 kilo ohm. I'm using the current divider again. First, figure out the correct connection. So 3K and 6K are parallel. And then this parallel series connected with this 1K here. And then they are paralleling with 2K up here to share the total 2 milliampere current. If this is fully aware, then the current of this branch here falling downward direction due to the current source current direction is equals to the total 2 milli times the ratio. Numerator is the other, which is 2 kilo ohm. Denominator is the 2K plus this branch total resistance, which is 1K plus 3K parallel with 6K. So the current of 1 kilo ohm is equal to 0.8 milliampere. And again, due to the current source direction, the 1 kilo ohm resistor current is downward. Okay, so this is something you have to be very clear why and how. Okay, and then last Ohm's law to give you the 0.8 volt contribution of V0 out of this 2 milliampere independent current source individually. So the last final result is V0 equals to sum of 3, total of 5.6 volt.